Let us go to the solution for getting top 5 daily products based upon the revenue. In that process, we'll understand how to apply filtering on top of the derived values using analytic functions. Let's load the SQL magic, and also let's create this environment variable called as database_URL. Now let us review the order of execution of SQL. But before getting into the order of execution of SQL, first let us review the order of writing the query. Typically, we write the query in this order. We start with select clause. As part of the select clause, we will have the columns, functions, etc. Then as part of the from clause, we might have one or more tables. When we have more than one tables, we typically have join with the on clause. On is typically specified for join condition. Once we have the join clause with the multiple tables, then we have where if we have to filter the data. Then if we have to perform any aggregations based upon key, then we use group by. On top of aggregations, if you want to perform any filtering, then you use having, which is optional. Typically having is used only for filtering on top of aggregated results, and it only comes with group by. Without group by, you will not be able to specify having. Then finally, if you have to sort the data, you use order by at the end. This is the order in which we typically write the query. Let's review a couple of queries to understand how the query is written. So in this case, I am trying to get daily revenue. When it comes to daily, we can get it from orders. When it comes to revenue, we can get it from order items, and hence we have to join these two tables. As part of the select clause, we have order date from orders and the derived field revenue, which is derived using order items subtotal. As we have to join these two things, on top of join, we also have on clause where the join condition is specified. Also, when it comes to computing daily revenue, we want to consider only complete or closed orders as revenue generating orders, and hence we have the filter like this. We have where o.order status in complete comma closed. As we have to get daily revenue, we have to use order date as part of the group by. As we want to sort the data based on order date, we have to use order by like this. This is how the query should be written. First select clause, then from with a join and on, then where, then group by, then order by. There might be few other clauses, but these are the most commonly used clauses while writing the query. If you want to filter for those dates where the revenue is greater than 50,000, this is how we can write the query. We can actually say having under group by, and we should be able to compare with 50,000 to get only those days where revenue is greater than 50,000. Now you can see that 2013 July 25th is filtered because on 2013 July 25th, the revenue is only $31,547. As we have the filter to only show those dates where the revenue is greater than 50,000, that is filtered. So this is how the query is typically written. Now let's understand how the query is actually executed internally. It will not start with select clause because we don't know from where the columns have to be read. It doesn't make any sense to go with select. It will start with from clause. As part of the from clause, we specify the table names. Using those tables, it will do the IO, and then it will get the data from the tables. If you have join with on, it will apply that on condition, and it will try to join multiple tables. If there is any filtering, the where will be applied. However, between join and where, it can be executed in any order based upon the query written and also based upon the explain plan that is generated. Don't worry too much about which one will be executed first. It can be either of them. It can be where first, then join, or it can be join first, then where. After from, join and where will be executed, then group by, and optionally having if we have having. Then select will be executed, then order by. Understanding this order is very, very important. As select is executed before order by clause, we will not be able to refer the aliases defined in select clause in other clauses except for order by. It is applicable for most of the traditional databases, including PostgreSQL. Now let us see few examples so that we understand what we are talking about here. So this query will fail because revenue, which is an alias defined in select, cannot be used in where. You can run this and you can see that it is throwing error saying that column revenue does not exist. We are using revenue here, which is an alias defined in select clause. This will not work. This will also fail as we cannot use aggregate functions in where clause. So in this case, as part of the where, I have specified the aggregate function. If you run this, it says aggregate functions are not allowed in where. This will work because revenue, which is an alias in select clause, is used as part of the order by. It is not used elsewhere. As the order by will be executed after the set clause, unlike other clauses, this will work without any issues. You should be able to see the results. However, if you want to get only those dates where the revenue is greater than 50,000, you should be able to use having. As part of the having, you should be able to specify the aggregate function like this. So if you have to filter on top of aggregated results, one of the approach is to use having clause under group by. Even though this function did not work with where, this will work. We can specify the aggregate functions like this as part of the having clause to filter the data based on the aggregated results. Now, when it comes to top 5 revenue generating products, this one will fail because we have drnk, which is nothing but alias that is specified as part of the select clause, and we are trying to use under where clause. So daily product revenue is the table which have date, product ID and revenue that is generated for each product for each day, and we are trying to use the table to get top 5 revenue generating products each day. People tend to use this approach, but this will fail, saying that drnk doesn't exist. You can see here. This is where you have to understand how to filter the data on top of those results which are generated using analytics functions. For that, we have to use subqueries. Let's get an overview of subqueries. We have already seen as part of this section earlier. I just want to quickly recap so that you understand how subqueries can be leveraged to filter the data on top of those fields which are derived using analytic or windowing functions. We typically have subqueries in from clause. We need to provide alias to the subqueries in from clause in PostgreSQL. Without alias, it doesn't work. So this is an example for a subquery. Select current date is subquery for this main query. However, with respect to this subquery, we have to provide the alias. In this case, alias is Q, but as is optional. You can have as or you can remove it. Still it will work. But alias has to be provided. In this case, Q is the alias for our subquery select current date. We use subqueries quite often over queries using analytics or windowing functions. We will see example very soon where these two are closely related. Before getting into the analytics functions and using them as subqueries, let's see few more examples with respect to subqueries. This is a bit more realistic example. This will give us daily order count. I have enclosed as part of the circular brackets and provided alias as Q, and then I am trying to just get the data from that subquery. Now this subquery will act as any normal table. You should be able to apply other clauses and perform whatever processing you want to perform further. You can see the output here. We are just sorting the data by order date. However, if you want to filter, you can filter. This is an example for the filter. In this case, using this field which is defined as part of the subquery, I am trying to get only those dates where order count is greater than 150. You can see the output here. Above query is just an example for subqueries. We can achieve using having clause. No need to have subquery to filter. Also, using this subquery is not a very effective way of filtering on top of the aggregated results. We should be leveraging having clause. I have demonstrated as part of this topic only a bit earlier. Go back and see how you can change this query to having clause to filter on top of aggregated data. Just to demonstrate the example for subquery, especially from the filtering perspective, I have used this hypothetical example. Now let's understand how to filter on top of analytic function results. We can use analytic functions only in select clause. We cannot use analytic functions in any other clause. Even in having clause, we will not be able to use. Typically, we don't use group by when we use analytic functions. It is an alternative for group by. There are some extreme scenarios where we might have to use both group by and analytic functions in the same query, but it is very rare. Typically, we use group by and then we apply analytic functions using the group by query as subquery, and then we try to filter again by using it as subquery in another main query. We will see that multi-level queries also a bit later as examples. For now, just remember that we can use analytic functions only in select clause. If we have to filter based on analytic function results, then we need to use subqueries. Once the query is added as subquery, we can apply filter using aliases of the analytic functions. Let's see an example to understand how we can filter data based on analytic functions. If you try to filter directly like this, it will fail. We have tried earlier also. It will just complain saying that drnk does not exist. It is due to the fact that the where clause will be executed ahead of select clause, and drnk is specified as part of the select clause, and daily product revenue doesn't have the column by name drnk. Now, if you enclose this as a subquery, as part of the main query, you should be able to filter using this alias. That is what we are doing here. In this case, we have enclosed that entire subquery where ranks are computed. As part of the main query, we are applying the filtering. This should work. So this is how you should be able to leverage the subqueries to actually filter the data which is derived from analytic functions. Without subqueries, you will not be able to filter the data. So make sure you are comfortable with both analytic functions as well as subqueries to solve the problems such as top 5 revenue generating products or top 5 salaried employees, etc.